Today we'll be looking at logarithms, and as you notice, the subtitle is working with exponents, and the reason for that is we use logarithms to write exponents, either very large or small numbers, in such a way that it's easy for us to handle. And the first thing we'll look at is how we write logarithms with as normal numbers. And so we look here, we have log base b of y equals x. And we would write that as b to the power of x equals y. Okay, and so again, this is my exponent, this is what it equals, and this is my base. It should be noted that if you see log without a number, this is log 10, and so we have log base 100. We would say log 100. We would say it equals 2, and then natural log is base e. And so if you see ln, that means base e. Both of these are very common uses, and you need to recognize both of them. So we look at log base 4 of 64 equals something, and so what this says is 4 to the power of something equals 64. And so x would equal 3 because 4 cubed is 64. And so I know that kind of off the top of my head, and I could say that. If I didn't, I would start dividing by 4 and see what I could get. On the bottom, the next example will be 2 to the power of 5 equals y. And so we just would multiply 2 out to get 32 equals y. And as you can tell, most of the logarithms will be used in calculators because we are using numbers that we're not used to. As you get used to it, we'll use easier numbers for you, and then we'll move up. So we look at our rules for logarithm. We have log base b of y times x, and so when we're multiplying two numbers inside of a log, we can add them out. So we can look here and see log base b of y plus log base b of x. And so if I do something like log base 100, I could then say, well, this is log base 10 of 10 times log of 10. And we add these up. So this would be 1 plus 1, which equals 2, and as we saw earlier, 10 squared equals 100. So that would work out for us. We could also divide our logarithm, so we have log b of y over x equals log b of y minus log b of x. Well, then I could do something like log of 5, and I could write that as log of 10 over 2, which will equal log 10 minus log 2. And so I don't know what log 2 is off the top of my head, but I know log 10 is 1, and then I could plug log 2 in the calculator. The last bit is x times log b of y equals log base b of yx. So we're going to use 2 log base 10. Well, we know this is 2 times 1, which is 2, or we could say log of 10 squared, which is log of 100, which again gives me 2. And so all of these different properties are useful for our logarithms. The last bit we'll look at is log base b of b to the power of x equals x. And so we look at this, let's say we have log of 4 to the 4th x power, and we'll say 3, and so this would equal 3. And we can look at it, we're asking 4 to the what power, and I'll use x for that, equals 4 cubed, and of course this is 3. The other one, we have b to the power of log b of x equals x. So again, we'll have 5 to the power of log base 5 of 6, and so this would equal 6 because these are the same. And so this is actually 5 to the what power equals 5 to the 6th power, and of course this is 6.